my dear friends, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for your GATE and ESE preparation. So very good evening, guys. Very good evening. I hope everyone is good, perfect, and if any problem with any technical difficulty if you're having, please do let me know in the comment section. Okay, so very good evening. Today we'll be starting a new subject of very interesting and very scoring subject from GATE or ESE perspective, that is industrial engineering. Right, I am saying this is a scoring subject because if you try to look back, the previous 5 years of questions, even if I'm talking about GATE or even if I'm talking about ESE, the questions level is not difficult, right? It is only if you're having a concept clarity, then you'll be able to solve any number of questions. Even if I'm talking about ESE mains perspective, ESE mains, there are many subjects where you'll be finding difficult to get the answer, but this subject, industrial engineering, is a subject where you can easily secure a good marks by using this subject. Okay, so it's completely conceptual subject, numerical conceptual. So that's the best part. If you know the concept, and you will be only asked the numerical problem from this subject. So that is a, we can say, one point which is being reclined towards our side. Okay, so very good evening. I hope everything is good and fine and perfect. And please do share this video to all of your friends so that they could also join to this session, and they will be having a very good 40 minutes basic that will be having a discussion. Okay, fine, all good. Chaliye. So I presume that there is no problem or any difficulty. So let's start our discussion on this LPP. So I'll be starting with a basic understanding what is linear programming problem. Then we'll be going into this graphical approach. Okay. Directly entering into the graphical approach or graphical method won't be justifying today's session. So we'll be starting from a very basic understanding what is linear programming, where we are using this linear programming, and what could be the applications in daily life that where you can implement this LPP, and how you can solve any problems when once you have formulated an LPP, how you can approach and solve by using this very interesting, that is graphical approach, and what is a drawback of using this graphical approach. Every single discussion will be done in this video, so make sure you are watching this session till the end. Okay, chalo, so let's begin the session. I presume that everything is good, perfect, and there is no problem. Let me introduce about myself. I hope everyone has connected with me on my Telegram channel, that is Mechanical by Suraj, and also a very important update, I have updated my mail ID. This is a new mail ID being created, so make sure you are saving this for future we can say communication, like suraj.s9@byju's.com, right? I deal with all the subject that you are seeing on the screen, so I presume that you know. Now, very important update, on 14th May exactly at 12 p.m. you're gonna have a exam, right? And you have to reassure yourself. Why I'm saying you have to reassure yourself, the reason being because you all have started your GATE preparation journey or ESE, any competitive examination journey. In between, if you're having we can say some test or examination that will be helping you out to reach your goal or destination that you have basically planned, that I need to get into PSUs, I need to get into the IITs, or I want to get into ISE for doing the PG program, right? So definitely you have some plans with you, right? And for that you have to do some practice and hard work. It's not a 1 or 2 days or 1 month journey that you'll be studying for 1 month and you'll be cracking with the single digit rank. Not at all possible. Seeing the current market trends, you have to have a complete dedicated step-by-step approach towards your goal, right? Okay, so for that, in between there will be some tests like this where you need to analyze yourself. So for that, on 14th May, please make sure you all are racing yourself so that you are giving this examination, because this is a scholarship test, and if you are able to secure 90% scholarship for your any program, right? So definitely that's the best we can say help that you will be getting, both monetary wise and also you will be getting the help we can say from psychological point of view, right? So let's begin the session. I hope so everyone has shared this video to all of your friends. अगर अभी तक शेयर नहीं किया यार कर दो, because today's session will be a very interesting one. Okay, so let's first of all let us answer to this problem. What do you mean by this term linear programming? Okay, what do you mean by this term linear programming? Because always we have a basic doubt or difficulty that so linear programming, we don't know the basic idea, just we know the formula and we know how to apply the formulation. Nowadays if you see, even in GATE or ESE, they're not asking you direct formula based problem. Like if you have concept clarity, then only you'll be able to understand what the examiner is trying to ask. Okay, so it's very much important that try to understand. Now linear programming, by the word, if I try to visualize, linear means basically we are talking about the variables which is in linear format, like x plus y or x plus y plus z. That means the variables that we are having is in a linear format, a linear equation. Now in this case, what is happening is, if I talk about the real life application, whenever we are dealing with a kind of situation where the resources are very, we can say, very less, there is some very much restriction to use the different resources. So whenever we are dealing with that kind of scenario where the resources are limited, when the resources are restricted, there we can apply this approach of linear programming to optimize our results. Let us take one example. Let us suppose you want to transport a product to Chennai, to Hyderabad and to Mumbai, right? And definitely we'll be having different costs. For to Chennai, to Hyderabad or Mumbai, you will be having unit price will be different. And let us suppose Hyderabad is having a capacity of 1000 units, Chennai is having a capacity of 800 units and Mumbai is having capacity of 1500 units. So definitely, and this is one office is in Delhi. Second office from where we can send the material is sitting in, let us suppose, Bhopal. Okay, so from there, if you're sending all the materials to the different destination, we'll be having some different costs, right? So there are multiple possibility. That means we can have multiple solutions, we can have multiple approaches towards this kind of problem. So there we are using this concept of linear programming, right? So whenever we are having restricted resources and we are having multiple number of solutions being possible, so there whenever we want to optimize our results, we always try to proceed by using this concept of linear programming, or simply we call it as LPP, linear programming problem, right? So it is the simplest way of optimizing the problem, right? And it is a set of linear equation that is used to optimize or used to find the to calculate the variables where we need to optimize the objective function, right? So now let us try to understand. Now we got an idea, LPP will be used where we are having some restriction in the resources. There is basically some adequate resources are there. Okay, many possible solutions are possible. So there we need to optimize our results, right? So here objective function basically refers to that function which we need to optimize. That could be a profit oriented, that could be a cost oriented, right? That could be the usage of resources. So here what we do, we try to either maximize the profit or minimize the cost, or we try to optimize the usage of the resources. And all these applications we can use by using a simple way, that is linear programming. Okay, please do let me know, is this clear or not? Linear programming, what do you mean by LPP or linear programming? Okay, so if I talk about what are the different we can say applications where we can use LPP, we are having like nowadays everyone is planning to lose weight, they are going for gym. So whenever you are going to gym, right, or whenever you are attending some yoga center, you will be having some diet plan will be there. Okay, you can eat n number of nutrients, but we always try to optimize the nutrients such a way that I'll be getting the best result, right? So in diet problem also we can apply the concept of LPP by having some specified nutritional requirement where the objective function will be what is the cost of food intake. Let us suppose I'm talking about manufacturing problems. In manufacturing also we'll be having many constraints, like there's a restriction that I cannot make a person to work beyond 12 hours. There's a restriction for that. There's a restriction of production rate because every machine will be having different capacity, right? So here what we can do, we can optimize the total cost of production by using this LPP. Even if I've told you one example of transportation problem where we need to supply the items from source to destination. There are multiple ways what we can do. So here what we need to do is we will be optimizing the cost of transportation, and same goes with assignment problem. I hope you know about what is transportation and assignment, because we are already studying this type of applications in LPP. We'll be starting from graphical, then we'll be going for simplex method, then transportation problem and assignment problem. Everyone knows about this, but might be some students might not be knowing about the diet problem or the manufacturing problems, right? So these are the different types of linear programming. Now, if I talk about transportation problem, let's take an example. Let us suppose there are 3 factories. From sending one item from factory 1 to warehouse 1, it is costing me C1. From factory 1 to warehouse 2, it is costing me C2. Similarly, it is C3, C4, C5 and C6, right? So definitely we are having multiple possibilities, right? We're having multiple possibilities, like some items are getting from factory 1 to warehouse 1. So here what we do, we try to send the materials from factory to warehouse in such a way that the total cost of transportation is minimum. That means here I'm talking about a minimization problem. Minimization problem. Okay. Here we are talking about minimization problem, right? Is this clear? Minimization problem. Okay. Chalo. So these are the basic understanding what is LPP. Now let us talk about what are the different parameters that we need to understand before going into the graphical approach. So the basic terminology is basically we are talking about 3 basic important parameters, that is your decision variables, objective function and constraints. What is decision variables? Let us suppose we are having a set of orange, we are having a set of apple as a raw material, and we are making a different categories of cake, right? So how much unit, how much quantity of apple is required, or how much quantity of we can say the second fruit is required, let's say mango, right? Mango is required in order to get the overall the profit will be maximum. So I can say the decision variables is basically the quantities that we need to calculate. Okay. Objective function is that function which we need to optimize. There we can say it could be a maximization problem. Maximization means we are talking about profit oriented. If I talk about minimization problem, I'm talking about we can say the cost or loss, right? Okay, fine. If I talk about constraints, constraints basically it's not like this. You can use 1000 kgs of apple or 1000 kgs of mangoes. There are always a restriction to the resources. There is never ever we're gonna have the infinite surplus source where we can take the raw material n number of times. We always be having some restriction. So constraints represents how the decision variables are restricted. What is the restriction that is being made? What are the we can say conditions being defined? Let's say it could be based on the production time, it could be based on the raw materials availability, right? So there are various constraints that we can have. So clubbing all the 3 basic terminologies, we can easily formulate a linear programming problem. Okay, so how we can formulate a linear programming problem? What we have to do, first of all, we need to identify what is the decision variable. Once we are done, the decision variable, it could be x or y or x1 or x2 or x3 or xyz, like this. Once we have identified what is the decision variable, second is we need to write the objective function. Objective function means whether we need to go for a maximization approach or whether we need to go for a minimization approach, right? So once we have defined the objective function, next is we have to write what are the different constraints, right? What are the different constraints we are having? And once we are having the constraints, and definitely this is a by default non-negativity restriction, because the decision variables will always be a non-negative value. Okay, so we always try to have this non-negativity restrictions will be defined. Okay, so by this way we are able to formulate any linear programming problem, even if you are using a graphical approach, even if you are using a simplex method, right? Fine. Is this clear? Anyone having any doubt till this point, please do let me know in the comment section, because many students, they are studying the graphical approach but they forgot about how to start the topic. Okay, first of all, you need to know what is linear programming problem, where we are using this, what is the application of that. Once we are done with this, how we can formulate the linear programming problem, then we'll be entering to the graphical approach. Okay, chalo. So let's proceed to graphical approach. Now, how we can formulate, how we can solve any graphical approach, how we can solve any linear programming problem by using graphical approach. It's a we can say 3 to 4 basic steps are followed. If I say the first step is you have to first of all formulate the linear programming. That means you have to define the decision variables, you have to define the constraints, okay, you have to go for a non-negativity criteria. Once you have formulated the LPP, second step is you have to construct the graph and you have to plot all the constraints. Once you have identified the feasible region, identify the corner points of that feasible region. Once you have identified the corner points of the feasible region, the last step is calculate the objective function at all the corner points and identify which point is giving us the optimum value. That will be giving us the optimum results. Clear? Hai? But there's a problem. The biggest drawback of graphical method is if you try to visualize, if I want to plot a 2D graph, I will be requiring two variables, two decision variables or two variables x and y or x1 or x2. But let us suppose if I'm having 3 different variables. So if you're having 3 different variables, it is practically very difficult to plot this graphical. Very difficult to use a graphical approach because normally graphical method is being applied whenever we are dealing with 2 constraints or 2 variables, not constraint, 2 variables, x, y or x1 or x2 or y1 or y2. Okay, so the biggest drawback of graphical is you cannot use this method if you are having 3 variables, more than 2 variables. Okay, not 3, more than 2 variables. If you're having 2 variables, best is go for graphical method because that will be giving us the optimum result in a very less time frame. Okay, but you'll be asking, sir, let us suppose if any LPP is having more than 2 variables, then what we'll be doing? Do we need to sit like this? No, you have to apply the simplex method, right? You have to apply the simplex method, right? And definitely I'll be telling you what is simplex method in the next class because today's session is solely about graphical method. Okay, clear hai? Can we proceed to the graphical method? Let us begin with the discussion because till this point of time, I've only told you about the basic understanding. If you are not knowing anything about LPP, if you study like this, I think you won't be having any problem in solving any questions. You take it last 20 years of paper. Even if you're taking the ESE mains paper, I can surely say you won't be having any doubt after this session. Chalo. So now let's talk about, let's take an example and we'll be formulating one LPP and then we'll be using the graphical approach. Okay, let us suppose we have to calculate the number of product 1 and product 2 for maximizing the profit. So we can say maximum profit means now we are talking about a maximization problem. So here the objective function, that is Z is you need to maximize. Okay, fine. Now if you try to visualize, here we are having 2 products, product 1 and product 2, right? Let's say I'm writing this product 1 as x1 and product 2 as x2. I'm writing this as x1 and x2. Okay, fine. So if you try to visualize, to manufacture product 1 or x1, you require 1 unit of raw material A and 0 unit of raw material A for product 2, and the total capacity available is 4. So can we write an equation like this? X1 should be less than equal to 4. This is the first constraint we have defined. If you try to visualize, if I want to manufacture 1 unit of x1, okay, it requires 1 unit of raw material A and the product 2 requires 0 unit of raw material A and the total capacity available is 4 units. So can we not say the number of units for product 1 should be less than equal to 4, right? Okay, let us talk about the second constraint. Here we are talking about in product 1, 0 units of raw material B is required. In product 2, to manufacture 1 unit of product 2, you require 2 units of product B. So can I say 2x2 is less than equal to 12? Yes, 2x2 is less than equal to 12, right? Okay, and the last one we can say 3x1 plus 2x2 is less than equal to 18. So here what we have did, we have created the constraints. First requirement is done. To formulate any LPP, you want a constraints, you want an objective function. Now if you try to visualize, the profit for manufacturing 1 unit of product 1, it's 3 rupees. I'm manufacturing x1 units. So can we say the objective function is equal to 3x1 plus 5x2? This is nothing but the profit I'm talking about. This is nothing but profit we are talking about, and we need to maximize it. We need to maximize this value. So here, if I rewrite this, the LPP, so here we are having an objective function which we need to maximize, that is equal to 3x1 plus 5x2, right? And we are having some constraint, that is x1 less than equal to 4, 2x2 less than equal to 12, and 3x1 plus 2x2 is less than equal to 18. Okay, so first one is the objective function. This is the objective function that we have defined, right? These three are the constraints that we are talking about, and definitely this x1 and x2 will never ever be having a negative value. Can we say x1 and x2 is greater than equal to 0? So this is your non-negativity criteria. Non-negativity criteria. Is this clear? Okay, so we have formulated the LPP. The formulation of LPP is done. First step is done. Formulate the LPP. We have done this. Second step is construct the graph and plot all the constraints. Chalo, let's do that also, right? So let us suppose this is your x1, this is x2, right? Now, how we can do? I need to plot all these linear equation on the 2D graph, right? So the first constraint is x1 less than equal to 4. Let's say I'm writing, let's say this is 1, this is 2, this is 3, this is 4, and this should be a rough graph, 5, 6, something like this. So x1 less than equal to 4, I will be having a vertical line, something like this. I'll be having a vertical line passing through 4. Okay, all the values less than 4 is acceptable. That means we will be having something like this. Is your constraint number 1. This is the constraint number 1. Always write the numbers whenever you are plotting, because you won't be having any doubt or difficulty in that case. Okay, chalo. Let's proceed to the next one. Now, second one is x2 is less than equal to 6. x2 is less than equal to 6, right? So let me write the value over here. So we'll be having 1, 2, 3, 4, 5, 6. Let's say this is 6, right? And x2 less than equal to 6 means we'll be having a horizontal line. Okay, so we'll be having one horizontal line, something like this. This is the second constraint. This is the second constraint. Okay. Now, third one, we can write it like this. This is in the intersect format. We can write it like this: x1 divided by 6 plus x2 divided by 9 less than equal to 1. We can write the third constraint like x1 divided by 6 plus x2 divided by 9 less than equal to 1. So once we have written it like this, let's place it. Let's try to plot it over here. Let's try to plot this particular over here. So this is 6 and the 9 will be somewhere around here. Let's say this is 9. If we try to plot, we will be having a region something like this. This is your constraint number 3. This is your constraint number 3. Yes or no? Please do let me know in the comment section right now. Alright, Samaj. So this is the region which is basically satisfying all the constraints. This is the region which is being satisfied by all the 3 constraints. So we try to identify the corner point. So this is, let us suppose, point A, this is point B, this is point C, this is point D, and this is point E. So we are having 5 corner points. Let us try to identify the coordinates of this corner point. So A is having coordinate, this is an origin. Now B is having a coordinate of 4, 0. Now, if I talk about point C is the intersection of constraint 1 and constraint 3. Now, constraint 1 is x1 equal to 4 and constraint 3 is 3x1 plus 2x2 is equal to 18, right? If you try to solve these 2 equations, we'll be getting x1 equal to 4 and x2 is equal to, place it, this will be 12, 18 minus 12 is 6, so it will be 3. Yes? 4, 3. Yes or no? Yes? 12 हो गया, तो 18 minus 12 is 6, so 6 by 2 is 3. So we'll be having 4 comma 3. It is 4 comma 3. Okay, now if I talk about point D, this is 4 comma 3. Now point D is having a intersection of constraint number 3 and constraint number 2. Constraint number 3 is again 3x1 plus 2x2 is equal to 18, and constraint number 2 is x2 is equal to 6. X2 is equal to 6. If you solve these two equations, we'll be getting x2 is already equal to 6 and x1 equal to, this will be 12, this will be 2. 2 comma 6. This will be 2 comma 6. Yes? So point D is having a coordinate of 2 comma 6. E is already we are having coordinate as 0 comma 6. Okay, so we have identified all the coordinates for the corner point. The point number second is completed, right? Point number 2 is completed. So we have identified the feasible region, we have identified the corner points. Now what we have to do? We have to evaluate the objective function. That means what we have to do is, what is the objective function over here? The objective function is z is equal to 3x1 plus 5x2. 3x1 plus 5x2. So what we do, we try to calculate the objective function at the corner point. So let us calculate the A. A is having a coordinate of 0 comma 0. So ZA will be having a value of 0 only, right? What about coordinate of point B? Point B is having 4 comma 0. So ZB will be equal to 3 into 4 plus 0, that is equal to 12. If I talk about coordinate of point C, C is having 4 comma 3, right? So we can say ZC will be equal to 3 comma 4, 3 into 4 plus 5 into 3. So this will be 12 plus 15, that is 27, right? If I talk about coordinate of point D, D is having a coordinate of your 2 comma 6. ZD will be equal to 3 into 2 plus 5 into 6, that is 36. And E is having a coordinate of 0 comma 6. Okay, so ZE will be equal to 3 into 0 plus 5 into 6, that is 30. Okay, so we have calculated the objective function at each and every corner point. Clear hai na? Chalo. Yes, understood? We have calculated the objective function at each and every corner point. So what we have to do is, we have to identify where we are having, because this was a maximization problem, where the objective function is maximum. So objective function is maximum at point number D. The objective function is having the maximum value at point number D, right? So once we know that it is having the maximum value, so I can say the optimum results, the optimum value is Z, that was profit, that is equal to rupees 36. And at how much will be the manufacturing of x1 and x2? At x1 equal to 2 and x2 is equal to 6. This will be giving us the maximum profit. This will be giving us the maximum profit. Okay, that means once, what is the meaning of this? The meaning of this is, if you manufacture 2 units, because you are getting at x1 equal to 2 and x2 is equal to 6, है ना? 6 है ना? 2 comma 6, 2 comma 6. That means if you manufacture 2 units of product 1 and 6 units of product 2, you will be having the maximum profit. You will be getting a maximum profit. If you are not doing this, then you won't be getting the maximum profit. Okay, so by this way, because I am having n number of possibility, I can do is, I can manufacture, if I try to visualize, I can manufacture x1 1 unit, that is also possible. I can manufacture x2 is equal to 0 units. I'm not manufacturing anything of x2, right? Product 2 I'm not manufacturing, so that is also giving us one of the profit. But I need to calculate the net manufacturing of product 1 and product 2 in order to maximize the profit, and that is nothing but when I manufacture 2 units of product 1 and 6 units of product 2, my profit will be maximum. And by this way, we are basically applying this concept in various applications, your diet problem, manufacturing, this was a question from manufacturing LPP, right? We can have the transportation problem, we can have an assignment problem also. Okay, so there are many applications, real life applications where we are using this LPP. So I hope you got an idea how we can approach towards the solution of this LPP problem using this graphical approach. So if this is clear, I hope so. Please do write in the comment section as soon as possible so that we can get an update that you understood. And if you have understood this, I'll be giving you one task, that is time to evaluate yourself. Okay, so I'm giving you a question that is solve the given linear programming problem. So it is already being mentioned, we are having a maximization of the objective function and there's some constraints being given. Okay, it's not a previous year question, it's a random question that you're having. So what you have to do, if you have understood this particular graphical approach, try to solve this question and try to post your answer in the comment section. Once you are doing this, in the next class, I'll be showing the names of the persons, those who have solved this question in the live session. I'll be placing the names of those candidates on my PPT. Okay, so let's hope we're having many students giving their answer in the comment section. Okay, so please, it's very much important. Only studying won't be giving you results. Time to time you have to evaluate yourself. Okay, so I hope so ये आपको समझ में आ गया. This is pretty much clear. So it's time to say goodbye and I hope so you have understood in a very detailed manner. I'll be sharing the PDF of this session on my Telegram channel also, that is Mechanical by Suraj. Right, I think that is all set from my side. And if you're having any doubt or difficulty, I'm showing the question one more time. The question is time to evaluate yourself. The question, the task I'm giving you is try to calculate the maximum value, Z value you have to calculate. Okay, you have to calculate the Z max value. And at which point of X and Y you are getting this Z max. Okay, fine. I presume that you'll be giving your answer in the comment section, and the next class I'll be showing the list of the students, those who are commented and they're given the correct answer. Those who have given the wrong answer, I'll be giving you an important, I'll be solving this question in the live session, don't worry. But first of all, you have to evaluate yourself, because once you have studied a concept, self-evaluation is important. If you're not self-evaluating, then how will you be able to understand whether you have understood or not? Okay, so I hope this is pretty much clear. I'll be sharing the PDF in this Telegram channel also, so don't worry about that. Okay, so thank you guys for joining with me. I hope you all enjoyed this session. So thank you, stay safe, stay connected and enjoy your preparations with this BYJU'S exam prep. Thank you guys, bye bye, take care, stay safe, enjoy your day, bye bye.